Hello and welcome to another episode of Learn Electronics with Radioshack. This time, experiment 76, inverting two power supply amplifier. And this one is a good one. I recommend that you watch the previous video about it's a non-inverting two power supply amplifier. Okay, so this part here, the whole thing here, this is the inverting. So you have two, of course, but this one is the inverting one. This one is actually a non-inverting one, used as a buffer. Let's look first at the power supply. So you have two batteries, 4.5 volt batteries, and the ground is here. And the power, so you have a positive power supply on 63, the negative power supply on 70, and it's a dual op amp, so it's the same here basically. Okay, so you only have 63, 70 to power both op amps. So let's talk about the first one. So this one is actually what's called a voltage follower, and it's a non-inverting op amp. And before that, you have the earphone, which is actually a microphone with very high impedance. And here you have the control, which is basically like a volume control on your stereo. It's just a voltage divider, very simple, and it brings the signal to the input to that first IC. And the role of that IC is to buffer that high impedance. Let me try to explain why you need this, but then I need to go to my trusted whiteboard. Okay, so this is the voltage follower, and sorry for my writing, that's pretty horrible. Voltage follower. So it's a special case of a non-inverting amp. And usually when you have a non-inverting amp, so of course the input signal goes to the plus, and you have a feedback loop, RF. In this case it's 0, but usually you have something. And here, usually you would have a resistor here going to ground. But in our case, Ri is actually infinity because it's open. So that's the voltage follower. That's exactly what we have in our circuit, the first IC. And what we need to know is that the amplification factor is 1, so there is no voltage gain. But the interesting part, of course, but that's true for any non-inverting amp, is that the Rin is infinite. So basically, when you look, if you consider this like a black box, when you look here towards the plus, the input impedance or resistance is infinite. It's infinite, which is always good. So why is it important in our case? The problem with our case is that we have a input signal which is coming from a piezoelectric microphone, so it's very high impedance. I'm gonna say 20 megohms, but maybe it's a bit lower, but let's say it's very high. So I'm representing this here. So this is my this is my microphone or my earphone. And RS is very high. RS is very high. So if you were to go directly to the load or to the next, if you were to go to the inverting op amp directly, you would have a big problem because RS is okay. So now you have to look at the inverting one and look at the Rin of the inverting amp, otherwise you won't understand what I'm saying. Okay, so let's go to the inverting amp, which is what we have as IC number 2 in our circuit. So this is the inverting amp setup. plus is grounded, and this signal comes through to the minus, but through a input resistor, and you have your RF in the feedback loop. But the interesting thing is that if you look at all this as a black box, and if you look, yeah, put it here, okay? Let's say this is just a black box for your amplifier. If you look here at the resistance or impedance that you are going to encounter, it's not infinite, it's Ri. So Rin equal Ri. So in our case, if I look at the schematics, Rin is equal to 1K. Okay, so now let's go back to the other one. So basically, if you were to connect the microphone directly to the input of the second IC in our circuit, the inverting op amp, that RL would be equal to 1K. Okay, because this is the input resistance for that second IC. We'll get back to the circuit and maybe it's going to be clear. But here you have a big mismatch because RS is 20 megohm and here you have 1K. Big problem. Here, all the power is lost here. So you cannot have that. So that's why you have a buffer amplifier in between. Okay, so now let's go back to the circuit. I think it's gonna be a little bit clearer. Okay, so we're back to that circuit. So here, earphone has a very large impedance. Goes through the control, it goes into an input that also has a very large input impedance. So that's beautiful. You have perfect transfer of power. Again, this is called a voltage follower. So amplification gain factor is equal to 1. So you have no voltage gain, but you get the current gain. So 67 is the output. So now you are fine. You can go into that 1K and you have a good match here now. So this is IC2. So this is your inverting op amp. And this is the classic setup. You have your the plus is connected to ground. And on the minus, you have your what I call Ri. And this is the RF. So this is the feedback loop. So the amplification factor of this guy is R1 over R2. And this is going to be 100, like the one we did before. So that would be number 75, experiment 75. You go into a speaker via an output transformer. And again, you need the transformer because of the impedance matching. So I talked about that in the last video. You can have a look at it. I'll put a link to the last video right now, so you can have a look at it. And that's about it. So I'm not gonna build this thing on the bench because it's kind of redundant with the last one. And anyway, in my case, I would replace the earphone with a signal generator. But since the signal generator doesn't have that problem of high impedance, you don't need the buffer. You can connect directly your signal generator to 75. Okay, so there's no need to build that thing. So anyway, I'm gonna stop here and I'll see you on.